favorite part about these Engine Performance Expos, or of the Expos, are these roundtable discussions, because it's like free form, open conversation. We've got such great minds, and we're going to have 2 in the next hour and 20 minutes or so. So you're going to want to stick around and let your friends know. But right now, Lake, we're going to get into something that is vital and important in this whole realm, which is testing. And I'm sure everybody's got their own spin on the best practices.
Of course, this is actually my favorite thing. I love testing. That was the thing that I loved the most about working with Mike and Mark and actually everybody here. To do testing. And that was one of the things that I think we learned really early on, that there's a right way to do this and a wrong way to do this. And so, Mark, why don't you talk a little bit about the method of the thought process of testing from Joe Gibbs Racing?
Well, the first one is ABA and BAB, and B. Yeah, test it more than once, because sometimes it's not true. But going back to a lot of testing you and Mike and I did together, it depends on what you're testing. It's like, but you also have to have the test equipment to see what your surface finishes. If you're doing lifter wear and oil and stuff, you got to make sure all your lifters are the same before you start.
Right.
So you got to have, even testing isn't just the dyno or this, it's the equipment that you have to make sure your test is going to be accurate.
Well, thank you for saying that, because that is the biggest thing. We spend, Ben and I especially, you spend so much time preparing for a test. Yeah. If you just want to test and you haven't prepared for it, you probably didn't do it right.
You're probably going to get the wrong results.
Yeah, right. I know, like when we were doing some of the oil testing on that LT direct injector engine, we probably spent 3/4 of a day just practicing making runs for how we wanted to do the test.
Yeah.
So setting up the test parameters, what the goal was, how long is it going to take to get a measurable sample. I mean, it was days and days of like wanting to suck on a pistol there and like, I can't stand this anymore, but like.
I used to just send my stuff to Mike and he did it.
Yeah. So, I mean, we finally came up with how we were going to do it, but it was like we had to practice how to do the test even. So.
Well, one thing about oil testing, Mike, was the double flush. I had never heard of that. I mean, I've been around racing my whole life, and I'd actually done oil testing when we were at Melling. Only realized we totally did it wrong, never once did it right. Explain why the double flush.
Well, in terms of double flushing, you do your test, right? You flush the oil. There's still components that are impacted by the previous additives that are sitting in the engine. So you need to flush it again to try to clean out that engine as best as possible before you start running a new test. Otherwise, you might get skewed results from that.
So it was like run the engine, drain the oil out, put new oil in, then run the engine for a short time again and drain that oil out, and then put the new oil that you want to test in, and it was just over and over and over and over.
Seems like a lot of waste of oil, but it's definitely necessary.
Yeah.
And you're still hoping the additive left the second time, and sometimes it did, because some of the good additives that were still in there, you know what I mean? So
they were designed to stick, right?
Back to making another oil look better than it really is, or worse than it really is that fact that, oil is 2 things. It's base oil and additives, and just because you drain that blend out, there's still additives on all of those parts.
Yes.
Yeah.
And you've got to run them out long enough. And one thing we would do is, like I said, you had your test oil, which is your baseline oil. That's just back to the AVA. You've got to have that baseline. And if you can't go back to that baseline and get the same number, something drifted in the mist.
You can't make it happen. You can't repeat it. Then it's not really that valid.
Right.
Hence your AB and BA and ABA and BAB. And so at some point you just go, I need to know that I'm starting from the same spot every time, and then you average what you get together so you can not fool yourself. It's real easy to, like I mentioned earlier, nobody ever questions the dyno when it spits out a big number, right?
That's a good one.
Yeah, this is awesome.
But we hate that thing when it shows low, right?
That's broken.
I honestly think we have more good dyno days than we have bad dyno days.
Yeah.
I think we have good dyno days as much as we have bad dyno days.
Well, back to the preparation and getting cams and lifters and all that. I mean, this poor soul, I put him through hell for all the oil testing we did, because how many camshafts did we make those poor guys in the QC department add coal?
Every lobe. And it was, we must have done, we do about a dozen camshafts at a time. We probably did it 5 different times. And what sometimes when you're testing, what's best practices for competition is not best practices for testing. When we were testing camshafts in competition, we would run the base circle as big as it could fit inside the engine. But these, we made them intentionally very, very small because we wanted to get measurable wear.
Right.
In competition on a cast iron camshaft, we would have always run it through a phosphate etch.
Yep.
Because the phosphate etch would put these phosphate, this zinc, this different lubrication to let the cam and lifter
begin to mate.
But we wouldn't run the phosphate in an oil test because we wanted to see what the oil's doing, not the phosphate.
Right.
So one of the main things that you wind up doing when you're doing any good testing is you're trying to eliminate variables.
Exactly.
The more you can, we talked to the VP guy today, and I told him that he's probably saved us, $20,000 this year on engines, because when we do all of our initial testing, we do it with a race gas,
right?
Not with a pump gas. Even if we're going to go back at the end and go back to a pump gas to test, because for calibration, but we don't want to have a unknown variable in there. So you're always...
And pump gas is an unknown variable.
Right.
100% unknown variable.
Yeah, unless you're going to the people, Exxon, BP, whatever,
right,
and getting a certified drum of test
reference
fuel that's like $100 and something a gallon. If you're not doing that, your pump gas is a big variable. So you want to control every variable that's inside of your control.
Right. And Mike knows all about that from your work at Lubrizol. I mean, you had reference oils, reference fuels for all the AS. I mean, how many dynos were at Wycliffe?
I hate to guess. Probably dozens, if not more.
Wow.
Yeah. It was,
it's not just controlling things like you're talking about, setting up our oil test or all that, but even like in power testing, right? It's important to control the variables of water temperature and inlet temperature, and get the engine doing the same thing, even on the tune-up, like on an EFI tune-up. I don't know, like your guys' experience, but I've always found, if the tune-up has a little rough spot or whatever, and you start a test, when you open the throttle and it comes up to whatever I'm going to hold at, if it coughs or snorts or jiggles or does anything there, it never seems to want to recover the rest of the test. That whole run, you could just throw it out.
Absolutely.
And so trying to get the test to do the same thing so that you can say, was that better or worse? Water, air, all those things are just as important as everything else that you're trying to control. When you talk about variables, man, there's tons of them that are going on all the time.
Yeah.
That's a great one within the run. Me and Mark were talking about it last night, driving back from dinner for a go-kart deal, because the inertia dyno, and most of them have clutches. At what point that clutch engages, how it engages, affects the rest of that run.
Sure.
And if you just want to believe the number that's good, you can totally lie to yourself so easily.
Yep.
I mean, you've got to run over and over and over again, and you've got to be willing to throw out the good and throw out the bad.
Well, and you tie that back into the earlier discussion today about fuel temperature, distillation curves, and all that. So, like, we race those same engines you guys have, but in junior dragsters, with my kids and stuff. And the temperature you let the cylinder head get on the starting line dramatically affects the way it converts that fuel from liquid to vapor. So the entire run in the 8th mile that we drag race is affected just by what temperature you let them leave the starting line, right? So all of these things are the same when you're dyno testing. It has to be a controlled variable.
I'm kind of anti-chassis dyno guy, because I look at our engine dyno, and you're trying to control temperatures, you're trying to control oil temperature, all these temperatures, and then you throw the bearings in on the brakes of whatever type of brake you have, your room temperature, and all this stuff.
Tire air pressure.
And then you go to chassis dyno. Now you have to do that to the transmission, the rear gear, the tire pressures. You had that. To me, to me, chasing a chassis dyno and looking for 1 or 2 horsepower is very, very hard. I mean, very hard. And I think it's hard on an engine dyno, let alone now you go to chassis dyno and you have 4 or 5 more components that make a difference.
So, Mark, I'll give you a great example of that, comparing chassis dynos, so roller-based versus hub-based, right? So a number of years back, I've got a good friend that's got a chassis roller dyno tuning shop, and so I finished work one day, go over to his shop to kind of shoot the bull, and he has a customer there that they're strapping this car on the dyno, and you're kind of saying, well, what are you hoping for and all that, and the guy says, oh man, I would love to make 1,000 horsepower at the tires, and I go, well, it probably already makes that and way more. It probably makes 1,200. And he goes, what do you mean? I go, well, look at how much that roller, by the time you strap it all down, is deforming the tire, and how much power or just raw energy would it take for you to put that shape in that tire? And he goes, wow. So I said, tell you what, why don't you guys do your stuff, and when you're done, drive it over to my shop, and we'll take the wheels off and bolt it on the hub dyno. So they made like 1,008 or something. He met his goal on the roller dyno. They took it off the dyno. They bring it over to my place. They didn't even plug in a laptop. Like no changes whatsoever. First pull, it made 1204. Yeah. Wow. There was 200 horsepower in the tires
friction
of just deformation, friction, all this losses that was a variable. So you could change the tire pressure on a roller dyno and get a different number. Right?
So, and we've seen it before. Like when we're doing, a lot of the stuff we want to do a cam test, we want to do it, in the vehicle, so we see how everything works. Yeah. But you can't be super precise like you're talking about on a roller dyno. Like we can do a cam change, but we can't take the vehicle off the dyno. Right. Like if you take the car and you can take it, do a dyno pull, change the camshaft, do a dyno pull, you're okay. But if you take that car, run it around the parking lot and back it up and put it on the dyno again, your chances of getting it, in the same exact spot, you're going to get it forward or back, or how you're going to ratchet down, what that's going to do to the pinion angle. You can't take one and drive it around the parking lot, put it back on, and be within 5 horsepower. Right. So when you're looking for 20 horsepower, changes, when you have plus or minus 5 just from bolting it on and off, you can kind of lose a 20 pretty quick.
Yeah, for sure. And I will say that is a huge difference between a roller dyno and a hub dyno, where it used to be on something where, I have 2 roller dynos at my shop and a hub dyno and an engine dyno. So we have a lot of ability to go back and forth and see. And it used to be, like you said, if you could have a twin turbo, say LS3 car that makes, 900,000, 1,200 horsepower, man, they'll change 40, 50 horsepower per run. Like you just don't know which way it's going to go. And it has nothing to do with your tune-up, When we moved from there to the hub dyno, we found really quickly that the vast majority of variables was in the tire. Right. So now on the hub dyno, for the most part, you can make run after run after run. They just stack up on top of each other, So that was probably the number one variable in the testing, even though all those other ones still exist. Like we did a bunch of differential oil testing on the Chevy Suburban, and hours of just driving that thing on the hub dyno, but again, it's about identifying and then controlling the variables that you can control. So.
I mean, oil level, big variable.
Oil level, sure. You talk about the variables in the dynos and stuff like that. We're tweaking the oil very slightly to see if that's going to change the performance of the vehicle or the engine. And if you don't get these other things right and get the variables out of those, the tests on the oil are pretty much meaningless.
The amount of plus or minus variable in your measurement system can easily exceed the change you were able to affect in the engine. So.
Which is why we had the measuring roundtable first.
Yes, exactly. Yeah. But go back to even like an engine dyno. You almost have to be careful of like the load cell you choose to use on an engine dyno, because it's easy to go when you're shopping for the dyno and the sales guy's saying, man, you never know what kind of engine you get. You better get the big one that'll handle 3,000 horsepower. But if I only work on stuff that makes 800 horsepower, I'm not using much of the resolution of my measuring stick. Yes. You know what I mean? So it's important to, if you got plus or minus 1% of 3,000 versus plus or minus 1% of 800, that's a way smaller room for error there. So it's important to kind of look at all that stuff.
Yeah, that'll make the spec fit the window versus the window fit the spec.
Yeah, exactly. Yeah.
So that brings up another good question: correction factor.
Oh boy.
I mean, that's.
How much time do we got anyway?
So we have 30 minutes on correction factor.
Back to the drift. Yeah. I think we've all seen that most dyno systems, the worse the ambient conditions are, it tends to overcorrect.
Sure.
So it's easy to chase.
Well, is it actually overcorrecting, or is the engine actually making more power?
Well, or vice versa. Is it making way less power?
Right.
You know? So the problem that I always find with the dyno cell is the weather station is correcting to some standard, right? Pick your number of which standard. There's a whole bunch of standards, which means there really isn't one, right? But my point is, you pick this standard and you say, okay, my engine's operating in this environment that has non-standard conditions. So what that does is it corrects the density of the air so that I get back to all my normal stuff. But what it doesn't really do is tell me what effect, how I got to that density had, right? So if I got to a really poor testing condition because my barometric pressure was low and my temperature was high, the engine behaves differently than if I got there simply because I added a bunch of moisture in the air and it changed the combustion efficiency of the engine, you know? So my weather station doesn't really tell me that part as much. At least that's been my experience.
And none of the correction factors correct. What correction factors do is tell you how much oxygen is available in the air.
Yeah.
It doesn't change how that's going to change your combustion efficiency. Because you can go in there, you know, if you take an older design engine like a big block Chevy with a, you know, that takes a lot of lead to it, and you run it on a humid day, it's going to make less power because from the time that sparks to that kernel happens to that flame front starts to go out, any water vapor that's in there, water likes water. You've seen all the meniscus and how you look in a tube and how water does its little thing. It has a lot of surface tension. So water molecules like water molecules. They'll gloop up into chains. And early on, before you've formed a flame front, that chain of water will get in there and it will slow that development of the kernel into a flame front by just a few milliseconds. That couple of milliseconds is like taking lead out, but it won't do it every time.
Right, it's not
now
consistent.
You take that same humid day and you put a 2-plug Hemi in it that has a much more efficient, that only instead of needing 48 degrees of timing, needs 22. Well, it won't be affected by that humidity nearly as much as that inefficient chamber will. The other thing you can do is we'll run different camshafts based on atmospheric conditions. Well, when you're testing at one atmospheric condition, that tells you how that system works at that atmospheric condition. When you go to, you know, if you have really cool, dense air, you could have a lot, it's going to act like it has more compression. That makes it make more power. That's not correcting for that. All it's correcting for is the oxygen density into it, not how your brake-specific fuel consumption, your measurement of your combustion efficiency. It's not taking any of that into account. But we all know that brake specifics change based on the weather conditions.
Yeah, or just to your point of changing the camshaft, you know, that pulse tuning that happens, you know, near or after bottom dead center when you still have the intake valve open, right? So the wave is moving roughly the speed of sound, but if you have extreme changes in port temperature, right? So say on a blower engine where you go from nice cool air when I start it up, but it might be 350 degrees at the end of the run, you could have a shift in that, you know.
You can absolutely change the density of that air column coming down, which makes the engine run differently. So the dyno's telling you the truth.
Right.
Under these conditions, I made less power. But your correction factor's only taking into account the oxygen density in the air. Nothing
It's not telling
else.
the whole story for sure.
Absolutely.
Well, that's why you had the big giant controlled air systems for the AVL, right? So it's not just the AC dyno by itself, but you also have.
Yeah, but I tell you, I have many fights in my own head about this one.
Okay.
Because you think about this, there's a lot of guys that, fortunately, I've been with somebody that we have lots of money to spend. It's not like little shops. You know, we got the air system that'll correct the humidity, the temperature, and the barometer. We at Joe Gibbs Racing don't use the barometer. Because you think about it, if you're trying to get to a 2992 every day, well, you better do something about that exhaust pipe then, too.
Yeah, for sure. Yep.
And that's what we've always thought, that's not really correct, because now you're basically supercharging the motor. If you have, if your outside barometer is a 29.0 today and a 29.50 tomorrow because a high pressure comes in, that exhaust pipe ain't seeing it, but you're trying to make that carburetor see the same barometer every day. That exhaust pipe ain't seeing the same, so it kind of throws your test off a little bit, I think.
No,
So,
that's true. It's no different than like when you look at a turbocharged engine. You got to look at both sides.
Yes.
What's the exhaust pressure and what's the intake pressure? Then it ends up affecting the volumetric efficiency, and you didn't intend for it to do that.
I think GM one time, I think they did pressurize their exhaust room to make it the same.
That's
I don't know that for a fact, but I knew that was being talked about one time. So
They even had the thing about the air going past the. Never mind. I'm not allowed to talk about that.
You can neither confirm nor deny that
Yes, I
situation.
can, yes.
Somebody might try to do something like that.
Right. So, Mike, in all your years of consulting for many different race teams, because that was the group that Custom Solutions had many customers in many forms of motorsports, what was the most common testing issues you came across? Because I'm not assuming. I'm going to assume based on all of our previous conversations over the years that when you guys show up, it's not like, oh, here's your first blend of oil. First time they run it, everything's great and perfect. You can go on. Life is good. There's an iterative process to get there, and some of that iteration is in their testing method as well.
Yeah, I mean, it varied significantly between, say, pro stock and cup designs. It had a lot to do with variables with regard to the build of the engine. I think that was the most difficult thing we had to deal with.
Just figure out the application that you're dealing with.
Right, that application, and then just building consistently, test after test.
You got to be talking about Jason Line here because my shit was right. Sorry. Sorry, Jason. He ain't here to defend himself.
Defend himself, right? Yeah.
Or one of your other old co.
Oh, yeah, okay.
Okay. But I mean, that was the most difficult thing. I think that was a frustrating part on most of the teams, is that trying to make sure they got the build right consistently, because we would come test maybe for a few days, then go back and review the data, come back a month later, try to repeat the testing, try to tweak the oils.
And they've made a bunch of changes to the engine you didn't know about, you're saying?
Well, possibly, but just to even build it consistently from
same clearances,
month after month,
yeah.
right? And so I think that was the most frustrating part.
I know at some point you banged it into Jason's head enough that his whole thing, his mantra was one change at a time only. If you change more than one thing, your test valid is just useless.
Yeah, don't try to do too much at one time.
Right.
Yeah, try to do more of an iterative process rather than.
And we did that with the formulations, which is back to why you end up spending $1 million in engines in 1 year doing testing, is because if you tested a bunch of different components, each formulation was one component change at a time. You wouldn't change an additive package and a base oil blend at the same time. They all had to be independent of each other.
Right.
And
it's no different than isolating the variables of a dyno test,
Sure.
right? You got to isolate the variables of the change.
Well, I'm going to tell you what, and I'm going to pick on Billy right now, but vendors are way better today than they was 20 years ago.
Yeah.
I mean, we could get, I'm just picking on you, say we get two camshafts, and before you bought your Landis, they weren't the same. So we built this motor and had two different camshafts on there. We didn't know they were the same. Vendors today, like Landis's five-axis CNC, more CNCs, we have gotten way more consistent in the past 20 years with being able to compare a motor to another motor too also. So kudos to the vendors that stepped up and bought better equipment, better machining to make our jobs even better for what we do,
And some of it is you just didn't know what you didn't know, right? And so
absolutely. You thought that hand grinder running that master was doing the greatest job in the world till you actually,
had a way to measure it.
Yeah,
it's the whole thing. It's one of those deals that when I started, we had just like 4 or 5 Burcos, and then we had 12 Burcos, then we had 16 Burcos, and we had 16 Burcos and a Landis, and today we have 8 Akumas, 2 Landises. That 90% plus of what comes out of our shop is CNC ground.
Right.
And why is it that way? Because we can control the quality of it. That's just one of these things that over the time, just because you're buying the same part from us that you bought 5-10 years ago. I mean, I know when I look back, when I get, every day I go by and look at anything that's come back. And when I look at the back of a camshaft and it has the serial number, it has the date on it. And when I see 2017, I go, And you know, and it's funny. Like in 2017, when I saw 2017, I was like, "Wow, this is some good
State
stuff."
of the art. State of the art.
But if you saw 2013, you went, "Ooh," you know. And I'm really hoping that if I ever look at a camshaft, and I see the serial number, and it's more than 3 years old, and I'm not a little embarrassed, I'm probably going to quit and go to Walmart, you know, and be a greeter, because I want things to get better every year. Learn how to make something better. You know, I hope that I know something in 2025 about grinding a camshaft that I had no idea about today. So much so that I'm like, man, if I could tell myself what I know now, I would do this differently. We'd do this but differently. It'd be a better piece.
Oh yeah. I wore Mike out on that. We always wanted to change. We always wanted to get better.
Right.
I don't know how many hundreds of test blends there must have been over all the years.
I lost count.
What if, and I hear this from racers a lot, like they got it, it's going good, and they're figuring things out, and then they lose it, and then they're lost. Is that something you guys experience when you're trying to sort out that A, B, A, B, B, A kind of thing, where like, oh man, now where are we? How do we go back? How do we get back to where we were?
Not picking on the vendors, but usually that comes from, yeah, we did change this.
Oh yeah, by the way.
Oh yeah, we changed that to tool steel, or we changed this from M2 to M4, but we think it's okay. Well, no, it's not. No, but yeah.
It's one of those things where, Joe, you're always trying to have a formula that you know you can go back to and say, okay,
Yes.
I got out, I lost my way a little bit. Let me get back to where I was. And when
Right.
you go back there and then it doesn't repeat, you're like, okay, hang on.
Yeah.
Like obviously something else changed, you know. And I think
Right.
that's a lot of it. You know, like the drag racer guys have that happen a lot. They get way out of sorts on a clutch or a suspension setup or whatever, and you go, okay, get the notes out, go back to, you know, we were in Charlotte, we ran good there before. Let's do that again. And then you go, okay, we're at least back here, or we can't even get back there. Something changed, you know. So
And that's why we did the measurement first, right? Because it
Correct.
used to
Yeah.
be, it used to be stuff like the rings getting set in, right? And you know, now you guys probably make what, 1 or 2 pulls and it's done.
Yeah.
You know, that's all done.
But every cylinder is checked, you know, before it even goes together to make sure the surface finishes right.
Correct.
Exactly,
The rings
and
are,
that's
you
the
know,
whole thing is-
another company, Total Seal, stepping up and making better rings than we had, you know, a long time ago. So it's all back to everybody's gotten better, you know.
Right. And without that measurement, the reason
Yeah.
the reason that this comes in, the testing, there's not as much guessing because the measurement is so much better. We know what's going on with each of the surface engineering, the testing, the measurement, everything, the lubricants, the fuels, everything's gotten better. So we generally, when things look weird, there's always a reason.
Mm-hmm.
The difference between 2022 and 2002 is we often didn't know what the reason was.
Yes,
Today we can pretty much measure, you know, it doesn't take a whole lot of time to check any of these things.
And as you pointed out, over that 20-year span, you know, I remember in 2000, 99, 2002, man, it would take you hours sometimes to properly break in a set of rings and a cylinder or whatever. And now, like, it's a couple of dyno pulls and the ports are dried up and we're ready to go, you know. And so some of that is what you're talking about, the measurement capability. First of all, learning, hey, that doesn't work. We need to measure that. How do we measure that? Right? Now we know what to look for. So not only has that changed, but it's changed the whole way we test engines. You know, like you brought this up the other day, like or earlier today, you said I was not used to testing engines that way when you came to the shop and we were doing this Expo engine, you know, and I'm telling them, dude, we're good. We did some warm up. We got some pulls on this thing. Like, let's go. And you were like, really? That's crazy. I'm like,
No, I know you guys are running 20 minutes.
Yeah.
2,500 RPM with 75 foot-pounds of load. What are you talking about? We didn't do that.
We didn't.
Try that on a top fuel motor.
Yeah.
Yeah.
Forget it.
Yeah.
No, but the thing that variable you said, and we kind of hit on surface finish. That's, you know, that profilometer rides in my backpack everywhere I go now, because I know now that surface finish, the surface texture, not the waviness,
The contour, the finish, the whole thing.
That's
Just not
one
the
of the
RA
things.
number.
No, not RA number. Lie to you, lie to you, lie to you.
RA could leave.
We don't even spec it on most of our
it's-
pieces
yeah.
anymore. Sometimes we do for a grinding wheel vendor
Right.
just to make them happy. But we don't spec RA. We look at bearing areas,
Yep.
we look at surface contours. But what's interesting is whether it's the camshaft finish, the camshaft surface, or the ring, what we've honestly done in manufacturing is let it get to its happy spot.
Yes.
You know, when you hone a block, you're already honing it to the finish that you know that old school would have worn to over time.
Yes.
Same thing when I grind a cam lobe and run through our MSE finish. The MSE system is about the grinding, and then we do the polishing just to kind of mow the grass. But that finish is, if you looked at one of your camshafts that had run 5,000 miles,
Yes.
the ending finish was like what we're making in the beginning. It's funny, you take one of these camshafts off the dyno, you wipe it off the rag, you could sell it as new because it's not worn in because we already put that, we pre-wore it.
Yeah.
For sure.
Well, thinking about surface finish this summer, we came up and did the video for the previous expo, and we went and visited the guys at Elgin, and we had the conversation about surface finish and the wrist pins and how they had it RA number, but it was too smooth. And they went back and changed the process based on the conversation we had there, and all of a sudden, it solved their problem.
Right.
Same material, same machines. All we did was just change the abrasive process. At which point, with steps from this abrasive to that abrasive, RA number really didn't move that much, but you created more valley that was able to hold the oil, so proper lubrication. So this uncoated pin went from failing to passing, just changing surface finish. And to the eye, you would have never known the difference.
So whether you're testing surface finish or engine power or oils or whatever, the key really was to control the variables. Understand what they are,
Absolutely.
control the variables.
Look at Ben, like putting a period on the segment right on the time. Like, this guy is good. You should do more media stuff. Oh, wait, he already does. He's got his own podcast. He's very good. But hey, this is not going to be the last roundtable. We've got one more to go. It's going to be a little bit more wide open and an opportunity to ask some questions. So put those up in the chat section. Gentlemen, this was great. I want to go test something, right? But I don't want to get lost. Lake, you and me next. We're going to talk about a new product from Summit.
Exactly, yeah. They're a great supporter of the industry. They got some cool new products they're helping them out with. So stay tuned and watch this.
Coming down the stretch here at the Engine Performance Expo. Lake, what a day it has been. What an event it has been. But we're not done yet. We still got a couple of cool things to, and these are familiar to me.
Right.
I've seen a lot, hanging out with Total Seal a little bit. I know a little bit about rings and some of the tools associated. One is familiar, one is not so much. Why don't you tell us a little bit more about them?
Okay, so like you said, the familiar one is the Power Ring Filer. Now this one, as you can tell, is not the Total Seal Blue.
No.
This one is Summit Candy Apple Red, because we've worked with Summit to create their own private label version of the Power Ring Filer. So it's available in 110 and 220 volts. It's 100% made in the USA, constructed at Total Seal. It's powder coated. Now what's really cool about this is they are offering these in pretty much any color your toolbox is. You want navy blue, you want candy apple red, you want day glow orange, green, or purple, they got it. Whatever color your toolbox is, you can get a Power Ring Filer from Summit to match it.
They know their audience.
They know their audience.
Racers. I always say motorsports and auto racing is a sport for people with obsessive compulsive disorder. And if your ring filer needs to be exactly the same as your toolbox, which it definitely does,
oh yes,
now you've got an option.
They got it. And it's got all the things that we would normally want to expect in a Power Ring Filer. It has a diamond dressing wheel. That means you can make sure that wheel is straight, so properly dressed before you file your rings. It's got a dial indicator, so you can get it right to the thousandths, so your ring gap setting goes super fast and easy. Even has a deburring wheel. I mean, this is the Cadillac of ring filers, and it's available at Summit right now in whatever color you want to match your toolbox.
So, okay, this is the Cadillac, which I love that reference, by the way. New standard of the world. And every once in a while I'll go in a trailer and I'll see them there with like a crank and everything, and I wonder, the difference between that and this. Is it because you're doing so many more engines, or what would be the reason you would upgrade to something like this?
Well, this is precision. Right, because you have a dial indicator and you have the dressing wheel on there, as opposed to having to hand crank and do all that and try to keep it square. I mean, this thing locks it in. That ring is locked in. It's got a squaring tool, and you can take out a precise amount. So really, this is about being precise and being productive. Now, there was nothing in between that hand grinder and this. Either you could do it like this, or you could do it like that. Well, Now there's a step in between.
Innovation. Here we go.
So pretty much everyone has one of these in your garage.
Or 3.
Or exactly, right? So this is one of the greatest inventions since sliced bread,
Yes.
right? So this is essentially this. It's an electric motor. That's what spins it over. So now, as opposed to spending, say, $800 for the Cadillac, now you can spend less than $300 and get this piece. So to turn it, all you do is put your drill on there, tighten down the chuck, boom, and you can spin away and you can ring fire. It's that simple.
You have all the benefits of the precision. It's taking up less than half the space in your trailer or wherever you happen to be using it.
Right.
And you can repurpose another tool.
Exactly.
So maybe you're not doing it all the time, but you're doing it enough that you want it right. I love that.
And what's really great about it is, so this is the base model. It's called the USA 1 ring filer. You can get it from Summit. It's exclusively for Summit. You can optionally buy the dressing tool, so you can dress the wheel if you want to have that little extra precision. Or you can even add the dial indicator to it. So you're essentially getting all the features of this with this as a modular component. So this is something really cool the guys at Summit asked us about, and we thought about it a little bit. And you know how Hartford is. His mind's always turning. So this is Matt's creation he came up with. So say, hey, easy way to take advantage of a tool you already have in order to get that level of precision that you really want. And again, it's available in the colors to match your toolbox.
And we've been talking about it over and over again. Like, if you're going to spend X amount of dollars for the best parts, the best pieces to build horsepower, why not invest a little extra in the precision? That's true for engine builders as well, right? Instead of
exactly.
grinding or coming, use one of these precision methods to make sure your ring gap is important, because it's correct, because it's important.
I mean, it's 100% important. You want to make sure it's square. You want to make sure you have the right gap. You want to be able to deburr it properly. These tools give you the ability to get that job done simply, easily, and in this case, crazy affordable. And you got some style to it too. You know, candy apple, or you want some day glow orange or silver, or whatever your style is.
I want the candy apple, Lake. You guys nailed it on the first shot with me.
Okay.
Like, and had me at hello. Had me at hello. And great to get involved with the folks at Summit, obviously. They are an industry leader.
Oh, man, and they do so much for the industry, right? So we're happy to have them as a sponsor here for the Engine Performance Expo. Obviously, great sponsor of NHRA and all the racing we love to do. So, yeah, great to have them on board, and we're proud to be working with them to deliver these cool products to you.
There it is. All right. So check it out next time you get your Summit catalog, and do like me, flipping through, dreaming of all the great stuff I'm going to get. You can dream about one of these, or you could actually get them. Summit.com, get their catalog. And I love that innovation.
Yeah,
at Hartford, he's always thinking. And speaking of people that are always thinking, we're going to throw it to our end of the day round table.
Yes.
This is one of my favorite parts of the Engine Performance Expo, because everybody kind of lets down their hair and just throws it out there. Great conversation. And I'm super excited.
Oh, it's always unscripted, just the impression. So you get these great engine builders, all their experience, and they're here in this pressure cooker of all these things going on, and they're hearing all these thoughts and different people speaking, and then you get to see their minds at work at that round table at the end of the day. Yeah, it's one of the things that we hear people say they really love about the expo. Not they don't like things like this, but they love to hear that just kind of unscripted, free-flowing thought at the end of the day.
Let's get unscripted. After this, let's go. What a day, what a day, what a day. My brain is swollen. I've learned so much today. They told us, don't start cars. We are not going to listen.